Hi everyone. In this session, we are going to see about the mechanical translation model. In this session, we are going to see some example of mechanical translation models and how to form an equation for a mechanical translation model, and then we are going to find the transfer function for a mechanical translation model. Okay. Now we know that for in a mechanical translation model, we are having mass, viscous friction, and spring. We have to calculate the force in the mass, friction, and spring in the terms of velocity. Then we have to mention F is equal to, if we are going to find the force in a mass in the term of velocity, then we have to write the equation as F is equal to m into dv divided by dt. For viscous friction, force acting in terms of velocity, we are mentioning as F into BB. Next, in terms of spring, we are for spring, the mass will be in the spring is calculated as, sorry, force will be in the spring is calculated as F is equal to K into integral of V dt. Okay, for the force acting in the mass, spring, and its friction in the terms of position, we are calculating as, for mass, we are calculating as F into m dx square divided by dt square, and for a friction, F is equal to b into dx divided by dt, and for a spring, we are calculating F is equal to kx. Now we are going to see an example of a mass spring damper system. Okay, in this system there is one mass, one friction, and one spring. Okay, note the physical linear systems are modeled by the linear differential equation for which linear components can be added together. Okay, we know that applied force will be equal to the actual force. Actual force depends on the elements, that is mass, spring, and friction. Okay, a force acting on mass in terms of position, that is x of t, is calculated here as m into d square x divided by dt square. For friction, it will be plus b into dx divided by dt. For spring, it will be k into x of t. These all are actual force. So actual force equal to applied force is here is F of t. So actual force, sum of actual force equal to applied force. Okay. Next, we are going to see an examples problem that is based on the automobile suspension system. Here we are having two masses, and the first mass represents automobile, and the second mass represents the wheel, and the third values, that is a spring and friction between the mass 1 and 2, is a suspension system. Okay, now the applied force will be in the mass 2, and in mass 1 there is no applied force. Okay, we are having the position as, that is displacement as, for a mass 1 the displacement is x1 of t, and for a mass 2 the displacement as x2 of t. Okay, for mass 1 we are going to write an equation, that is, yeah, for mass 1 the force acting on a mass 1 will be a force in a mass 1 and the spring and friction. Okay, from this we are going to calculate the value, that is applied force equal to actual force. Here for mass 1 there is no applied force, therefore we are calculating the actual forces along the free body diagram of mass 1. Okay, in that we are calculating as m1 into d square x1 of t divided by dt square equal minus of b. Why we are calculating as minus b means, in terms of applied force equal to actual force, we have to calculate everything in a positive value, that is elements force are calculated in the sum of values, but equal to 0 means it is calculated in terms of equal to 0, then the spring and friction values are comes to the right hand side. That's why it will be denoted as minus value. Okay, for minus b into the friction that will be connected between the two masses. So first we are going to write the mass which we are writing now. So we are considering the mass 1 here. So we are considering the displacement 1 first. After that we have to minus and then give the value of mass 2, that is minus b into dx1 of t divided by dt minus of dx2 of t divided by dt minus k, that is a spring also connected in between the mass 1 and 2. Now we are writing the equation for mass 1. So first we have to calculate the displacement value of mass 1 first. So k1 into x1 of t minus of x2 of t. Now we are going to write the equation for mass 2, that is m2 dx d square x2 divided by dt square f of t is equal f of t minus of b into dx2 divided by dt plus dx1 divided by dt. Here we are writing the values for mass 2. So we considering the displacement of mass 2 first, then we have to consider the displacement of mass 1. So I am writing here as d2 dx2 minus of t, sorry, dx2 divided by dt minus of dx1 divided by dt minus of k1 into x2 of t minus of x1 of t minus k value, that is k is only belongs to the mass 2. Therefore we directly write as k2 into x2 of t. Okay, some more example of the masses are given here. Mechanical rotational systems or translation systems are given here. Here for a mass we are considering as, we know that f of s is equal to k into x, f of b is equal to bv, or in terms of displacement that will be b into dx divided by dt. A net force of mass is equal to u minus of f of s minus of f of b. Then we have to calculate these values. M into d square x divided by dt square equal u minus of f of s minus of f of b equal u minus of k of x minus b into dx divided by dt, or m d square x divided by dt square plus b into dx divided by dt plus k into x equal to u. On continuing this equation, we are going to take a Laplace form for this. So we know that in a Laplace, differentiation values will be calculated as s. On taking Laplace, we have to calculate a differentiate value as s, and the that is in terms of t, it will be denoted in terms of s, that is m into s square x of s plus bs x of s plus k into x of s equal u of s. Now we are going to find the transfer function. How to find the transfer function? We know that output value of Laplace value of output divided by Laplace value of input is our transfer function. So now we are going to calculate the output value of Laplace divided by output value of input value of Laplace. Here we have to mention that in the form of x of s equal to 1 divided by M.S square plus bs plus k. This will be our transfer function g of s. Okay, in a problem we are going to see how to find a transfer function. The first problem is the write a differential equation governing the mechanical system shown in a figure. Determines its transfer function. So we know that we have to consider a transfer function. That is, we know that a transfer function is nothing but the Laplace transform of output divided by the Laplace transform of the input. So first we have to find out each and every values for mass 1, mass 2, everything. So first we have to draw a free body diagram for mass 1. In that we have to mention the force that will be applied in the mass 1. um, First we have to write a force belongs to a mass, that is Fm1, and the force belongs to the friction, mm, that is connected below the mass m1 as fb1, and the force acting force in a friction B that will be connected in between the mass 1 and 2 as Fb, and the spring in between the mass 1 and 2 as Fk, and the spring that will be act as the Fk. Okay, for a for this, we are going to write an equation, that is by a Newton's second law, applied force equal to a actual force. Here there is no applied force, so we have to write it as 0, and the actual forces are F of m1 plus F of v1 plus F of v plus F of k1 plus F of k. We know the formulas for the mass, friction and the spring. Using that, we are going to fabricate the equation, that is m1 into d square x1 divided by dt square plus b1 into dx1 divided by dt plus b d divided by dt x1 minus of x plus k1 into x1 plus k into x1 minus of x equals 0. On taking a Laplace transform of above equation with a 0 initial condition, we get m1 s square of x1 of s plus b1 s into x1 of s plus bs into x1 of s minus of x of s plus k1 into x1 of s plus k into x1 of s minus of x of s equal to 0. From this, we are going to taking a common value of x1 of s from the equation, and common value of x of s from that equation. We are getting x1 of s into m1 s square plus b1 plus b into s plus k1 plus k minus of x of s into bs plus k equals 0. So x1 of s is equal to my m1 s square plus b1 plus bs plus k1 plus k equal to x of s bs plus k. Now we want to find the value of x1, so we are going to divide the value of the right hand side with the multiplication value of x1 of s in the left hand side. So we get the value as m x1 of s is equal to x of s into bs plus k divided by m1 s square plus b1 plus b of s plus k1 plus k. Now we are going to write the free body diagram for mass 2, as well as we are going to form an equation for mass 2. In this mass 2, the displacement will be x, so we are considering the displacement as x here. After that, force acting on a mass. After that, we have to calculate the force acting on a frictions. After that, we are going to calculate the force acting on a spring. Okay, here there will be an applied force that is denoted as F. Okay, so applied force equal to actual force, we are writing as Fm2 plus Fb2 plus Fb plus F of k equal F of t. Now we are going to write the equation as m2 d square x divided by dt square plus b2 dx divided by dt plus b into d divided by dt x minus of x1 plus k into x minus of x1 f of t. On taking Laplace transform of above equation with 0 initial condition, we get m2 s square x of s plus b2 s into x of s plus bs into x of s minus of x1 of s plus k into x of s minus of x1 of s equal f of s. X of s into m2 s square plus b2 plus b into s plus k minus of x1 of s bs plus k equal f of s. Now we know the value of x1 of s from the previous equation, so we are going to substitute that x1 of s here. After substituting, we get x of s into m2 s square plus b2 plus bs plus k equal, sorry, k minus of bs plus k the whole square divided by m1 s square plus b1 plus b of s plus k1 plus k equal to f of s. Now we are going to taking the Laplace transform, we are going to take a LCM for these values. After that, we are getting as x of s into m1 s square plus b2 plus bs plus k the whole multiplication of m2 s square plus b1 plus b of s plus k1 plus k minus of bs plus k the whole square divided by m1 s square plus b1 plus bs plus k1 plus k equal f of s. We know that the output value, the Laplace transform of output divided by input is our transfer function. So here the input value is the force, that will be applied force, and the output value is the displacement, that is a x of s. So x of s divided by f of s, we are going to calculate the values by in this from this equation. So we are going to invert this value to this side, and we are going to take this f of s to the denominator here. After that, we are getting the transfer function as x of s divided by f of s equal m1 s square plus b1 plus b s plus k1 plus k, m1 s square plus b1 plus b of s plus k1 plus k, m2 s square plus b1 plus b of s plus my plus k1 minus of bs plus k the whole square. Okay, from this we are finding the value for transfer function. Thanks for watching this video. Thank you.